And welcome back. So, as previously stated, we are resolving this issue right here, which is that our plates for the x-axis are running into the plate that we're using to support the z-axis. The z-axis we've decided to do something a little silly with here. We're going to put the belt directly under, or at least this was the intention. The intention was to have a single extruded, a single piece of 2020 extrusion running straight up, because we're not anticipating a lot of weight on this end here, and therefore we're going to try to give it a shot to run just one piece of extrusion straight up and support that with brackets. The problem here is that this plate is accommodating the entire motor right now. Again, the simple solution here, because this plate does not actually overlap the shaft, would to be simply to put a coupler on the shaft and run a piece of 8mm out to the extrusion and then run the belt from there. So that would be the simple solution here. We're going to do something like slightly less conventional. And the reason I'm saying that is because, frankly, all we have to cut if we were to do that would be like 2 inches of 8mm rod, and that just feels like a waste, cutting 8mm or 2 inches off an 8mm rod just to get it out of the way. I mean, heck, I say 2 inches, it may even be like an inch. Well, no, it's probably more like 2 inches once you include the coupler, because it's got to be inside the coupler. Point being is that seriously seems like a waste to me. So for that reason, and I say 8mm because I'm pretty sure that's the size coupler I have. I don't think I have any 5mm couplers. Anyway, back to the topic at hand. We're not doing that. Instead, we're going to move the motor over, and then we're going to use pulleys to redirect the belt to drive the z-axis, or the x-axis rather. One other thing that I have noticed just now is that I never went ahead and put the tie-ins for the axis in here. And by tie-ins, I mean these little tabs right here is how we're doing that. And furthermore, with the extrusion in here, I'm wondering whether or not I want to do something slightly different. We can think about it. And the reason being, okay, actually, yeah, that does change quite a bit, doesn't it? I probably should have caught that earlier. So in theory, if I wanted to, I'm thinking, actually, all right, so if I extend this all the way out, extend this x-axis all the way out, and then run the belt over here. Oh, that's why. Okay, never mind. I take it back. I was thinking about running the belt over here and then having the extrusion over there. We actually did talk about that one last stream. Duh. And the reason we're not running the belt parallel to the extrusion is because of the torque on the single piece of extrusion. If we decided to go with 2 pieces of extrusion and then belt in between, then that'd be one thing. But because we're not doing that, because we're trying this out and we're putting 1 piece of extrusion and the belt in line with the piece of extrusion, we're doing that specifically because we don't want to create torque. If we're only using 1 piece of extrusion, put the belt on either side, it doesn't necessarily matter which, but the fact is that the belt pulling on the carriage to move it up and down would create a lot of torque on this 1 piece of extrusion, which is the big issue. So, and that is the issue we're trying to avoid. I am just doing a quick sanity check if there's anything else I wanted to change here, aside from moving that out, whether or not there's any other options that I have not necessarily thought about. One of those things, I was working on some little projects. So I just got that new drill I got, right, that I showed you guys 2 streams ago. I'm actually redesigning, or I'm designing an attachment to go onto the battery base of it, because the battery base does not stand on the table terribly well, A, and B, I actually like having belt clips. I know some people don't like belt clips for power tools, but I like belt clips for power tools, so this one does not come with an option for mounting a belt clip, so I'm making one. So I was working on that on the lunch break and have not put terribly much thought into this. Because, again, I had a plan of attack anyway, which was just to move the belt over, move the motor over rather, and use the pulley to redirect. But now that I'm back over here, I am reconsidering my options really quick, and one of those things, I think we just go with what our plan was to begin with. Yeah, I think so. Okay. One other thing actually that I did think of right as we were ending last stream is motor on top. If you look at the Prism Mini, let's open that back up. Not components, examples. So the Prism Mini puts the motor all the way up top here for the Z-axis. And that is, in my opinion, only reasonable because the weight of the motor is directly in line with the lead screw and is supported by these 2 linear rods right here. So you can see how those linear rods are directly in line with it. If we were to try to do something similar with that, like that, and put our motor on top, it has to go sideways because we're using a belt. It's a bit awkward to try to redirect the belt 90 degrees in the opposite direction. So if we had it upside down like this, we'd have to then redirect the belt to go vertically like this, which is awkward. I believe it is technically possible, but like I said, very awkward. And we are not doing that. But if we were to lay this down so that the belt would still be in line here, it's a matter of this weight right here. Again, I'm using the larger motor on the Z axis, so this is the one that weighs even more than the little guys. And that much weight hanging, free floating off space. Actually, you know what? I think I just... Oh boy. Okay. I think I just changed my mind on the fly on this one. And I will explain to you why. So the bottom still does get a little bit awkward with the idler going around the bottom side. But the big benefit about putting it up there is that obviously nothing can get in the way. We just make the Z-axis tall enough. We can extend the Z-axis infinity high, you know. In which case, however high we determine the X-axis needs to travel to be maximum height for the X-axis, we just add enough to compensate on the Z-axis for the X-axis plates. So let's hop back over here. If we drag this all the way up here, let's say this is right now, because I don't have anything else on screen to reference, this is maximum height. This is as high as I ever want this machine to go, because let's say I decide that any higher is too much for this extrusion, the 2020 extrusion, to hold it up. Well, in that case, I just put this right here, right? I just put the mount right about here and we're good, and this can't crash into it, because this extrusion right here, the Z extrusion, I don't particularly care where it goes. Now, again, the pulley is going to be on the bottom now if we do that for the belt, but it's not that big of a deal because it's just a pulley, right? So it's only whatever this is, 10 millimeters diameter. And our pulleys are actually slightly different sized than these guys. Then the idler pulleys are slightly different from the driving pulleys. That says 15 millimeters. But point being is that that's significantly less to have down here. The reason why I'm suddenly changing my mind here is that it occurs to me that the belt is going to be pulling on the front side of the motor, which is actually going to counteract the weight of the motor a little bit. So the torque of the belt being pulled down, you know, pulling down on the belt in order to support the X-axis, that actually does help some. And we are not going to be having any, there is no reason why I can't, let's see. Let me think about this a second. Even if I'm going down, right? Yeah, I actually, all right. So I think the plastic, can support the weight of this motor. Let me go grab the motor for a second. Let's see. It should be back here on the table. There it is. Alright, yeah. So this motor is relatively heavy. It is definitely heavier than the other ones. And I don't want to... So actually, here's an option. An option is to swap this... see, I wanted the 2 amp motor. This is a 2 amp motor, I'm pretty sure. I wanted this 2 amp motor on the Z-axis specifically because Z-axis is moving the most amount of weight. I'm pretty sure. But in theory, if this becomes a problem, I could swap this out. Again, it's all just NEMA 17s. So I could just swap this out with the Y-axis, the bed, swap the bed motor out for this longer one, and put the lighter Y-axis motor on the Z-axis, assuming, I believe that's a 1.3 amp motor. So assuming that 1.3 amps is enough torque for the Z-axis. All right. So yeah, this is an option. I actually do think this is an option, putting this up here, and it does make our lives a lot easier. All right, you know what? I'm willing. It's one of those things. This whole entire thing, this single-armed mini CNC, is all an experiment at this point. It's all, you know, how much torque can this thing actually hold? One of those things. I've got 2 M4s in here on the plate. It's all plastic. You know, we're testing the limits here. So, may as well go whole hog, right? I've used that word like 2 or 3 times so far over the past couple of streams. I don't know why I suddenly decided that that's a word I'm using. Alright, that being said, I guess I'll start from the bottom, define the pulley, just to get that out of the way. And then we'll set a maximum height after that, I guess, question mark. So it's one of these things. I don't have a good intuition on what is too high. So, frankly, alright, let me just get us started, because now I'm looking at this piece of extrusion that is on the x-axis that I showed you on the x-axis. Back to, I don't have any uses for it, and it is too short at this point, I'm pretty sure. I'm 99% sure. It is too short. Let's see. About 12 inches. Yeah, this is definitely less than 12 inches. Is it? Actually, that's pretty close. Tape measure. Tape measure. I'm pretty sure this is too long for the calipers. Okay, when I said this is pretty close, do not take my word for that one. That is not pretty close. Okay. So yeah, this is too close for the x-axis at this point. But again, the z-axis, I'm not sure what, how tall I really need the z-axis to be. Furthermore, yeah. I was going to say it's not too difficult to cut a new belt if I need to extend it. So if I decide that the z-axis needs to be taller, I could cut a new belt. The reason I stopped myself there is because, frankly, I don't want to have to keep on buying belts, you know. So I've got this scrap piece of belt that I showed you on the x-axis during last stream, and this is, let's see, that is about 22 inches ish, maybe somewhere in the 22 inches, and I'm just eyeballing that up based on other measurements I'm aware of. So it's about 22 inches, which in half is about 11 inches. And then you need extra space for pulleys and the tails, you know, which means that after you're done all that, we're down to something like 8 inches travel distance max out of this thing, which makes it very not useful, but at the same time, it's long enough that I don't feel like throwing it out, which is the problem. So for those reasons, I'm trying not to create more scrap pulley belts sitting around. Rather, I don't want to create more scrap belts. So I'm a little hesitant to just slap the 8-inch extrusion onto this thing and say I'll swap it out later, but maybe I do, maybe I do. I think I have a couple more cutoffs at work, and maybe I just grab one of those instead. Yeah, alright. I believe that is everything to talk about at this point. So, we are going to... Let's see. If I come up here, is there anything else I'm missing? Because I'm pretty sure I'm just scrapping everything we did up until this point. Yeah, I think I actually roll all the way back here. Back before this positioning. And delete everything after that just because it is no longer relevant to what we're doing. And then this is, yeah, that's the backside of the extrusion, so we can start with that again. And once again, put a, well, let me get back into the Z-axis and Z-axis plates. There we go. So I can hop back into here and start again with the Z-axis plates to hold the pulley. And this is just a passive pulley. Actually, we probably want to tension this pulley on this side because the motor... Alright. No, we can... So the motor can... motor's a little difficult to tension up and down. We probably want to affix the motor to the top of the extrusion. It's questionable, it's questionable. So tensioning the motor, like we've been doing for all the other sizes, is a bit difficult, so it may be better to make this tension down here, this pulley tension instead. We'll look at it. There is an interesting way that we have not incorporated yet for tensioning pulleys that I haven't done on stream before, that it would be nice to at least demonstrate. That would be applicable here. I mean, it's a little awkward just with the X carriage in the way. So you tension. So here's the problem with having a belt on the Z-axis, is that the Z-axis, well, the X-axis on the Z-axis is going to drop when the power's off, because it's only held in place by the electronic current, the magnetic force inside the motor. Unlike a screw, where the screw's friction and pitch basically can hold a Z-axis in place indefinitely, it's not really going to want to slide. Unlike that, the belt is just plain going to go loose, and then the X-axis is going to drop down to the bed. Hopefully not destructively, but we are working with all plastic. So one of those things I might want to keep an eye on. However, point being, is that we want to tension this. We'll want to tension this while the machine is off, right? In theory, which means because we're pulling on the belt, right? Because we're pulling on the belt and we want the motor to be off while we're pulling the belt. In theory, it may not be 100%. It may not be 100% necessary, but it's probably easier to do. But however, that means that this plate then is going to be down, nearly touching where we're trying to adjust down here, which is a little bit of a problem, is all I was trying to say. So at this point, this is our center line. We technically do have an option of where to put the motor. So I had the motor going this way. It didn't necessarily matter if the motor was going this way or this way. If the motor's going this way, I did not consider. So it doesn't matter in terms of this is still going to collide with it. The X gantry is still going to collide with it if we leave it down here. So we definitely do have to move it somewhere. But if we're driving the Z motor from this direction, or even this direction, because we now have the motor at the very top. So now we even have this direction as an option. It was not as much an option here, just because we don't have as much space, although it looks like we probably had enough. We probably had enough space that we probably could have, but it was not as obvious. Point being is, if I drive it this way, the belt is going this way, and then the belt ends. I was kind of leaving it up in the air where I was going to tie the belt ends off at. And it's a shame I already printed this. I did print this one face really quick because it was 40 minutes and I had about an hour to spare before stream. I had about an hour to spare before stream, and all my other stuff I'm printing right now is all an hour and a half plus. So I figured, I'll knock this one out. But I could put slots into here and actually run the belt straight through this plate if the belt is going in this direction. If the belt is going in this direction, so the belt loops over here because the motor is this way, then that's actually a rather convenient place to grab and tie off the belts. Huh. Alright. I might have to reprint that piece in that case, because that, again, is very useful. Like, that is very convenient. I'm not adding any external features, I'm adding a hole. That's why it's convenient, just to clarify. Okay. So in that case, our idler wheel would actually go this way. That is, in fact, more difficult to get to tension. At least the way I was thinking about tensioning it. Oh, no. That is the way. Okay, that is the way I would want to go tension it. No, it's not. I take it back. I lied. I got my brain mixed up now. The belt is going this way. The belt is going this way, which means that the idler is facing that side, which means that I cannot get the bolt through it. Okay, cool. Alright, yeah, so we do have to change this plane. So let me Control Z, because I do think, actually, now that I'm thinking about this, that this is A, more interesting, and B, potentially more useful to have the belt going in this direction. Actually. Huh. Alright, now I'm wondering which direction really is better. So I didn't want to put it off this side, okay? I didn't want to put the motor off this side because that brings our overall bounding box out more. So we're adding more clunk over here, which, you know, kills this space right here because it moves up and down. Or, well, actually, it doesn't actually move up and down. The motor stays right here. But if we have anything here in the way, then that becomes a problem. Point being. Whereas if the motor is here, then obviously there's nothing that can be here. So it's not that big of a deal. However, the reason I bring this up is because now I have the lever arm here of this extrusion plus the carriage on this side, and the motor also at the top of this extrusion pulling it this direction. Whereas if I put the motor off this side, then that's actually pulling the Z-axis back this way in theory, providing some counterweight to the X-axis. So it may actually, even though I don't want to take up space on this side of the machine because, again, it's making the machine wider, even though I believe that it may be better off nonetheless for the integrity of the machine to put it over on this side. So let's do that. Okay. Boo. Alright, so let me just really quick. Yeah, okay, yeah. I am thinking about this correctly, so let's go. Did I already make that plane? I want the plane on this side now. Thank you. Alright, so once again, I will grab these sides just to give myself a reference, and the center just again as a reference, nothing else. Let's turn the y-axis off and the y-axis and the x-axis. And actually, I don't need these right now either. Alright, cool. Clean slate. Clean slate. Alright, so we're going to have a pulley down here. The pulley can frankly, so let's assume this is the ground right here, which it should be. It should, in theory, be the ground. That can be tangent to the ground. That's fine. The pulley, the idler pulley, let me grab... Oh, actually, we have that in the components. So let me pull that up really quick just to make sure that I know the outer diameter of it. Alright, the outer diameter is 18 millimeters. Close you. So this is my outer diameter is 18 millimeters. And my ID on this guy is M5. 5. And as I was saying, so we're going to put this up on feet, right? Since we're putting this up on feet, it is one of these things where you'll recall earlier I was talking about how we might run plastic out from the extrusion to this. Well, I'm thinking now, since I'm going to be putting this up on feet, we probably definitely want to do that. The only question becomes how I go about attaching this, because you kind of want the extrusion, you kind of want the Z extrusion on top of that other piece of extrusion, so that that piece of extrusion, rather than plastic, is the thing supporting the weight ultimately. But at the same time, well, the other benefit of that is that, let me look at this really quick. There's that, and there's our x-axis. Okay, so we do have space. We don't really have space, do we? Yeah, we kind of do. We kind of do. No, we don't. We don't, because the extrusion has to stop right here. So because the extrusion has to stop right here, we don't really. Okay. My point was, let's see. My point was is that I wanted something solid underneath this because it's holding up the whole entire x-axis, but I don't have the space, it looks like. Because as you can see here, let me turn sideways. Here's the top of the extrusion, so this is the top of the extrusion frame. And then here is the bottom of the wheel right here. So as you can see, I've got like very, very little space between here and here, which is not nearly 18 millimeters. So I can't put a piece of extrusion here and then also have the wheel right there, is the issue at hand. And that's it, again, just to clarify, assuming that the extrusion comes all the way out past this, so that the Z extrusion can connect to it. Alright, I take that back. So, yeah, okay. I don't take that back. I lied. The Z extrusion at least has to come down to here. That's right, because I need to put a plastic bracket between the Z extrusion and the bottom in order to accommodate this pulley. Alright. I changed up the design all of a sudden, now I gotta rethink things. That is what's going on here. So at this point, I'm probably going to have to shim up these. Yeah. Alright, let's just get this built and then we'll figure it out from there. Okay. So this is going to be dead center. Dead center. There's that. This is a pulley. This is extrusion right here, which means that my walls to attach to the extrusion are going to be here. Right? And then I'm going to need a wall in front of me to attach the pulley to. I can't reasonably, because of these wheels right here, I can't reasonably attach the walls in line here. So let us go ahead and project out the bottom of this wheel here. So in theory, this is the absolute highest that the extrusion can start at. So we should probably give ourselves a little bit of playroom here just to keep ourselves safe. So let's make it 2, even though we can do something much less than 2. But just to keep ourselves safe, we'll do that. And that is obviously right below there, but at this point the whole entire system will be shifted up on feet, so we will have play underneath here. And these are theoretical at this point. Those are theoretical at this point, so I just need to finish off this what you call it, this right here. So this hole is for the center of my pulley. I want to make this a slot, so right now I'll go ahead and make that what you call it, let's see. The wall I'm making right here does not necessarily have to, it doesn't necessarily have to come all the way up to the top of the pulley. The pulley can be partially exposed. For that reason, I am going to go ahead and make it a bit shorter. The question is, how short? I guess I will just leave myself the 3 millimeters here and call that a day. Okay, that's round about there, that's fine. And then the slot, again, this, keep in mind this is going to be up, so this slot will allow it to go past the floor, but that's okay. So here's here on this line here, tangent to that, and we decided last time 6 millimeters. So just to get a reference, this is not staying here, but I'm going to delete this in just a second. But that is the bottom of the pulley when it is most stretched out, when the pulley has the most amount of tension applied to it. And that means that we require feet that are at least 4 millimeters tall, which is plenty. The feet are probably going to be a good bit bigger than 4 millimeters tall, so we are definitely 100% a-okay there. Alright, cool. So let me go ahead and extrude this out. The one problem here, actually, I said I wanted to do something different with the tensioning. We can make it work. Okay, it's going to be a little bit awkward. Basically, I'm going to have to turn the machine over at this point, but you'll see what happens when I go ahead and apply that. This is just a pulley, so I think I'm going to leave this at 3 millimeter wall here. And this is, so what I'm thinking is that this is going to be less Z-axis plates, plural, and just a Z-axis box, honestly, is what this is looking like at this point. So I'm going to leave this as new body because I don't think we're making more components. I think I'm actually legitimately just making a box here. It's going to be an open box, but a box nonetheless. Let me double check my sketch really quick. Here is my 18 millimeters. 18 millimeters is, in fact, according to my sketch, less than 20 millimeters. Science, right? So, yeah, sometimes I get a little too paranoid. 18 millimeters is, in fact, less than 20 millimeters. I just want to make sure that the 18 millimeter pulley fit inside the extrusion is all I was doing there. Okay, dokes. All right. I actually am now at this point going to put the other extrusion plane back in here. This is outside extrusion plane. This is back extrusion plane. Okay. Because again, this is going to end up being a box because I want to support, want to bolt to the extrusion on the front and back rather than trying to work around these wheels right here is the reason why I'm bolting here instead of just using this pulley plate as the mount for the extrusion. That is the rationale here. Again, just grabbing my center, grabbing here, and I can actually grab here because this is right up against it, so I will. It's maybe not the best idea just in case something happens, but it is very, very unlikely that something is going to happen. So, actually, one more thing I need is the top of the wheel here. Because, or not even the top of the wheel, this clearance right here. This clearance right here is what I need. Because that is where the extrusion is going to start, and then I need to go past that to get the bolts on there. So let's turn that off so that I have an easier time to see. Turn the bodies off, turn the x-axis off, and turn the z-axis extrusion off. So we need to bolt above this line because this is where the extrusion starts. And I am just going to define this like this because this is just a construction line. This is all going to be plastic, so I don't need to. Let's see. Yeah, the T-nut is going to be going this way, so it doesn't necessarily matter. So I can have this M4 go tangent to this. Again, M4 might be too small, but I'm going to attempt it at this point. Again, experimentations in this build. So there is that. And then I want one more. One of these things. I maybe should have just extended the other line up through the M4, but we're not going to worry about it. And this guy does need 3 millimeter. Whoops. This guy does need 3 millimeters around him. Tangent. And now I can throw my whole entire bounding box in here. This is collinear here. This is collinear here. This is collinear over here. And this is just... oh, actually I do have a collinear right here. Cool. There we go. And... wait, what happened? That was not supposed to be collinear. That was silly. That was definitely silly. This is supposed to be tangent up here. Alright, there we go. So that is where that is going to mount. Bodies. And... Actually. Let's hold off on this for a second and get this other guy mirrored first. I do not have a mirror plane in this axis. I have a mirror plane on because of the x-axis in the other direction, but not this one. So let's go ahead and grab our x-axis extrusion, toss a mid plane in here. Actually, I'm going to toss 2 mid planes in here. Which are you? Let's turn you on. Okay, you are the Y mid plane. Y mid plane. Z-axis Y mid plane. And now let's grab construct mid plane, that, and long click. Wait, how did I end up with 2? Oh, okay. Because I already had the Y mid plane selected. There we go. There's that. And I picked opposite corners right there because, as you can see, Y midplane ended up offset because I was going between just these two edges right here last time. So this makes it more towards center. Technically it is center, but technically if those were offset by any, it wouldn't be center. Point being is just that it looks nicer. It's a plane that goes for infinite distance, even if it looks short. Planes. So it's just for looks. So let us come down here and mirror this over, and then I'm going to extrude and connect to these two guys is the plan. That guy, adjust is fine. It's a very simple thing. It's not doing anything particular. Then this guy, I want to actually turn this back solid and then project out this guy. And I'm going to go ahead and extrude all of that so that this is all connected. And this will be 6 millimeters because this is holding the extrusion. And then we can go ahead and mirror this guy. That feature across the X or the Y, across the Y. And it just looks like it did correctly, so that is good. Now, the next thing that I'm going to do is toss I do have this line right here. So I'm going to create a bottom of. So this is one of those things I tried to avoid doing this earlier on, but I've been running into more situations where it's just plain easier to use this plane at angle. Again, because the plane at angle does not have a reference plane option, I feel a little bit uncomfortable doing it. It's just that I've gotten so used to doing it at this point that I've given up. So that is the reason why you're seeing me use plane at angle a lot more often. Bottom of extrusion. I don't know why I did plane on these guys. That's a little silly. It's just one of those days. I was a little silly this morning too. Just one of those days. Alright, now that we have that, we can come over to here. Modify, align our bottom to that guy. Okay. And should be good for now. I didn't have to do this right now. I just wanted to get it up and out of the way, so especially because now we can look at it right. And as you can see, the center of the wheel is above that. That's why I use the bottom of the wheel, because I know for a fact if I use the bottom of the wheel, the contact point will be above the bottom of the wheel. Whereas if I tried to get dead center here, the CAD could be slightly off, and therefore this extrusion might be a little short. You know, these holes where it's holding the extrusion, I should say, rather, might be a little short. So that's why I use the bottom of the wheel instead. It does obviously limit our space a little bit, but like I said, at this point, we are going to be tensioning this in a slightly different manner. Alright, so now for, as I promised, the way I'm going to be tensioning this. I'm trying to decide. So there's a couple different ways I could attach this. I think it's a little bit more interesting the way I'm going to do it, I think. And however, it's Alright, give me half a second to think. Just because it is a little it is a little eccentric. Yeah, you know what? Because I'm going to do it this way, I am going to add the extra meat on up top here. So let me go ahead and do that. Z plates. This guy is what I'm looking for. And again, this guy right here, I just did tangent here, but I think I am going to go all the way up. Collinear with that. And these guys were not well constrained, so let's go ahead and fix that. And in theory, these are just 6 millimeters. That was just me planning out the walls right. So there's that, just to be consistent. And that should be kosher still. I don't think I screwed anything up at this point. So the way we're going to do this is, again, a bit exotic, but is interesting, which is why we're doing it. So I'm going to come down here to the bottom, and I am going to let's see, yeah, we'll put them down here. Okay, you're ready for this one. This one's gonna be artistic, very artistic. So this, just to keep in mind, this is the way our pulley is going. The bolt is going through this way. I am going to draw a box here, and then inside of this box, actually, let me get rid of some objects really quick. Get rid of that guy. And what other sketch is open? How did I project that? I didn't. I guess I projected it. For some reason, I have no memory of projecting that, the bottom of the object, but I did need it. I did need the bottom of the object. I'm just, for some reason, I have no memory of projecting it. So anyway, I am going to put, let's see. Yeah, it's got to be 2. It's going to have to be 2 on either side. Okay, I can't get away with 1 on either side. I'm going to put some nuts in here. Let's grab our center line to reference off of so that everything can be equal. There's going to be a bolt going through the center right here along this line. So I want to space these out so that they are equal distance from that. There's that. And yeah, all right. We can, let's see. This is an M5 bolt, right? So let me draw that in really quick just so I keep in mind that that is here. Grab this line, make this centered on that. Yeah, I should do this over here, shouldn't I? Makes sense. All right, cool. And make sure that is dimensioned correctly. M5. All right, cool. So now I have a reference for that. And these are just reference lines as well. So here is my nut that I promised you. Let's see. Probably better to put in this orientation because that should be the skinniest orientation. And we will do M3s. Let's see. So it could be an M4, but that feels like overkill to me, especially because we're using so many. So I'm going to go M3s. And let me just check what our offset is if I am using M3s, because might want to. All right, so it's not quite 2 millimeters here. And actually, here's the other way to properly do that. There's that. Oh, derp, I can always make it bigger. That is a good point. That is an excellent point. All right. Yeah. In that case, this is now 3. Not you. No, not you. You. There we go. You, and you. Okay. I can just mirror this. I already have the mirror planes, so I can mirror this around. So I think I will. So as stated, this is an M3 with an M3 nut. Try to grab this edge to make it parallel to that guy. And you can be, I guess I'll make it tangent to this top one because we have the space. And then this top ledge will just be so this is overall, how thick is this wall? This wall is getting pretty thick. This is 12. That wall is 12. Okay, that is pretty thick. Let's drop this down to 2 then. Alright, so that is dropped down to 2. And then the question is, if I go down to a 2.5, I was just looking at these for my other project, and that was a 5.3 is what that is. So we're not gaining much by going down to... or 5.3 was the head, wasn't it? What was the hex? Hex might also be 5.3. Anyway, point being is that we're not saving much going down from here, going to a 2.5. So, and I'm not going to a 2. I am 100% not going down to a 2. So it's staying at 3. Point being. This is now at 10 millimeters. This doesn't really need to be that heavy. I'm going to put it at 4 just so it's slightly heavier. But let's see. Then I want this to be symmetric across here. I can just put a dot in here. I don't have to put a whole entire line. There's that. These are... Actually, no, I do need this line. I don't need that line. There we go. And yeah, that also needs to be kept in line. Midpoint here, please, and kept in line. There we go. All right, cool. Now everything is symmetric. So this is a little shelf embedding a nut. And so let's see. I actually probably want to go down with it now that I'm thinking about it, so I will go ahead and turn this back and turn that back to make my life easier. Just because of this slot right here, this slot being so low, I don't really have the space. So this is -4 because we're capturing our nut in here. So that gives me 2 for the nut and 2 for the... so 2 for the nut is a little optimistic, but... so I mean not 2 for the nut, but 2 millimeter wall from the nut to the top wall has me a little concerned just because we're going to be using this to tension, but we'll see how it works. And then that all the way through, distance all, and then we just do our mirrors really quick. Those around that guy. And actually, let me do this. I try to remember to do the right click. It's just that sometimes the right click doesn't show up is my biggest problem. The reason why I don't most of the time is that I'll try to right click and I'll get this squiggly line instead of an actual right click. This squiggly line right here. And then as you can see, the menu doesn't show up anyway, and I'm concerned that I'm accidentally adding something. I'm accidentally doing some kind of command with the squiggly line is my biggest concern, which is why I don't normally right click repeat. Just for the record. Now alright, so I know I said that we were going to flip this over to do this. We don't have to though. I can just lift the x-axis out of the way and still do it from the top. So let's actually do that, especially because I already put the hexes in the bottom here. So since I already put the X's in the bottom here, and actually, let me go ahead and offset these guys really quick. That was not accurate. New offset. Minus 0.05. And then add that to the mirrors. Okay. Okay. Alright, there we go. Anyway, back to the story. So, the deal here is that we are now going to replicate this ring on the bottom, or on the top rather. And this is my artistic way of resolving this situation of adding a tensioner. 2. Oh, right. I need these lines to be solid at this point because we're going around the outside. Here we go. From object there, -2, or -4, I guess, rather, or +4. I'm not going to argue. New component. And this is the tensioning ring. So we will have M3s on this guy going down to these M3 bolts, and then to tension the belt, because we'll have a shaft coming through here, right, for the idler wheel, a shaft slash screw, you know. This will then get tensioned down or pulled down by the bolts onto that through bolt that's going through the pulley, thus creating tension. That is the idea here. That is my creative way of resolving this issue, or doing this design, however you would like to phrase it. And I'm actually thinking now to delete that. Yes, delete it. You guys are fine. Stop crying. Just forget he was ever here. You don't need him in your life. And I can go ahead and distance all symmetric. Okay, fine. 2 sides. If that's how we're going to be, 2 sides. All in all. Alright, fine. Fine. That side. Distance to object. That side. Are we happy now? Are we happy now? That is those 2. So that is good. And we will go ahead and move these 2 guys up. Attempt to move these 2 guys up. Alright, never mind. We're deleting those guys. Yes, you do not actually reference anything. See? You do not actually reference anything. It's fine. Oh. Evidently you do reference something. Why do you reference something? That should just be the bottom here. That's all this was supposed to be, was just the bottom. Huh? Alright, there we go. Now we can come back in here and mirror around all the stuffs. Not that stuff though. All the other stuff. So that will include the holes now. Just trying to be efficient with the timeline. Do 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 boo boo doo boo doo boo doo boo doo boo doo. That guy, not that guy. That guy. There we go. And also include this guy, please. Plus this guy. There we go. Okay. Alright, cool. There we go. So yeah, so bolts come down here, pull down the pulley, and the pulley gets tensioned. There we go. And that is the creative way to tension this pulley. Let us go ahead and grab that pulley and bring it in here, I guess. And I will make it... Will I make it part of this object? I don't think I will. No. We will go ahead back up the Z-axis and bring him in. Insert into current design. Okie dokies. Modify. Align. That guy. On that guy. That guy. Flipperoonies. Okay. Capture. Oh, don't capture. No, don't capture. I take it back. Where's that movement? You need to be... actually, it looks like this guy has a center line on him. That is good. Or maybe he doesn't. Maybe he just has sketch plane. That's the origin. Okay, his origin is the center line. Okay, we can align you with that. No. No. Align you with that. There we go. All right. And now we can finish position. And now I'll come back in here really quick to the Z-axis, and not by really quick, I mean we're coming back in here. As built, get this and this rigid. So it's not really rigid, it's slider, right, along here. Sure. We can call it that, and we'll go ahead and do this as slider as well. That and that. Slider. Okay. And we can even motion link these two. That and that. And that is accurate. The only thing is our starting position is a little off, but I will cry about that later. It's fine, it's fine. We're compensating for the head of the bolt to begin with. Back to, I'm probably going to put a bolt through here. So the bolt head is going to stick out above that anyway. So it's not that big of a deal. Now, the final and most important thing is that this is kind of free floating in place, right? Just kind of hanging out here. It's not actually anchored to anything, which is a little bit of a problem. Let's see. How do we want to resolve this issue? Let's turn the other stuff on that we are considering. So this is going like this. So I could build out. Let's see. So again, as previously stated, the lower limit for this guy is only based on this bed. The lower limit for this guy is not actually based on anything, so this could be connected along the side. So I could slide this down, drag this down to in line with the feet. Okay, so this is now on the floor with the feet, and then tie this into that somehow, either with an extra bracket or whatnot. So that could be our solution here. I think I'm going to, in that case, wait just a hot minute and yeah, I'm gonna wait a hot minute on that guy and then design that at the end after we're done doing the feet. But before we do the feet, I want to finish off the Z-axis as promised, and that entails putting the motor mount at the top. So at this point, I will now go ahead and extrude this guy up, and actually just to make sure that it actually joins, because 3 different times so far this morning I tried to extrude a face and it did not join. So let's go up 400. No, 400 is huge. Yeah, 400 is huge. Let's see, 100. 100 is small though. 200. Yeah, 200 is fine. Yeah, 200 is fine. Again, this does not actually matter right here. This gets compensated by the extrusion itself. I changed how I'm cutting the extrusion and the belt as mentioned earlier, which means that inside the CAD, anything we design here literally does not matter. So, just taking a quick peek around. All right, now I will come up here and let's see. Yeah, I will go ahead and hop back in here actually just to put this top of extrusion plane in. Top of Z-axis. Okie dokies. And now we'll come back up here and make a new component. Z-axis motor mount. Use that plane we just did and project that out. And then Let's see. How do we want to go about this? Huh. We have options, right? Well, I mean, we don't have many options. We actually do not have many options. But I like to pretend like we have options. We have some options. We technically have some options. So I do kind of want to have the motor mount overlapping this and then put slots for the belt to go through. That's kind of what I want to do here. So I think I will. It's maybe not the best of ideas, but it's an idea. And again, I want the cantilever of the motor mount on the x-axis to help balance out the z-axis. So the motor will go on this side. So I'm going to put this box here. I'm going to give ourselves 6 millimeters on either side. This is going to end up extruded downwards around the extrusion. So here's the question. How many sides do I feel paranoid enough about? That is a good question. Maybe I just extrude down on these sides. Alright, maybe I just extrude down on these sides. 6 millimeters and 6 millimeters here. I'll leave those 6 millimeters there, just keep it square. But I think I will extrude these guys down here. These guys down here. Let's get that lined up. And the same on the other side. One of those things could use mirrors, especially because we have those planes set up, but just as quick to just extrude them. And then I need this gap in here for the belt to go in. I don't really want to get that point. Again, just in case something happens and I gotta deconnect the point, that's always a pain in the butt. I will go ahead, however, and let it overlap the extrusion. So you'll see part of the extrusion through the hole here, which is no big deal. I don't think it should be a problem. Alright, there we go. And then the platform for the 1.7 inch 1.7 inch. So let's get that squared up on here. The motor can technically the motor can hang off the backside here. I've done that before. It's not that big of a deal. But just for the sake of sanity, we will not. We will instead, this is 47 millimeters is what this is saying this is. 47. We will go ahead and make it full length of the motor. So that is the motor mount. And then just for looks, I'm going to go ahead and square off these corners. And by square off, I mean let Fusion put extra lines in here. Alright. And this can be a construction line just to make my extrusions easier to do. And there is that. So this is going up 6 millimeters again. Again, we're just going extra safe with the 6 millimeter depth. And then I'm extruding out these guys along the sides to bolt to. So minus, so per their arcade stick, experiment. For M4s, well, for M4s, here's the thing. Now that I'm on top of the extrusion, how I'm mounting this to the thing, I was thinking about going M6s, honestly, to mount this plate to... actually, now that I said M6s, I could use my metal corner brackets up here. That wouldn't be super unreasonable. It would add a bit of weight, though. I mean, the weight is counteracted, but at the same time, it is still weight. So, my point that I was going to make was that now that this is sitting on top of the extrusion, I'm less concerned about it, about what size bolts we're using. I'm less concerned about what size bolts we're using to bolt it to the extrusion. Because the bolts, frankly, all they're doing is stopping it from twisting around this way, laterally, axially, however you want to put that. They're not really doing anything. Well, I guess they're stopping it from tipping this way a little bit, although what I was planning on doing was putting a loft here to support it. I was planning on putting a loft here to support it, so that, again, is not that big of a deal. Although, it's one of those things that does eat up vertical space. It does limit my, So, let's do this really quick, then. In that case, let us go ahead and bring some of these corner brackets up. Yeah, they are quite big, aren't they? Okay, modify a line. Try to modify a line. So there is that. Flip it over and then modify a line. And what was the best way to get these guys centered? Let's see. Corner brackets. Mid-planes. Do I have a mid-plane running down the center? That would be awfully useful. I do not. Okay. Where's the sketch plane? That sketch plane is on the bottom. Okay. Let's see. Do this. Okay, that is kind of working. The flip button is not necessarily doing me any good, but this is fine. This is fine. We can make this work. Modify, align. Actually, let's do this one first. Because I'm lined up in this orientation now, right? Yeah, so now I just have to put it back where it was. Okay, cool. Which we know how to do. We did this before. Alright, there we go. So that would be one of my metal brackets. Again, it's a little big, but at the same time, I don't have to worry about the flex at all using it. Now the question is, do I want to put another one on the other side? Which I guess I may as well. Why not, right? So let's go ahead and do that. Insert. Align. And we'll do it the other way this time. We'll start out with the center of this guy. On that. Okay, or maybe not on that, because that is somehow not the correct. Huh. Let's see. Okay. Is that good enough? No, that's not good enough. Let us try this side. Alright, there we go. That is good enough. Good, 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 good. Fusion's a little silly sometimes in my opinion, but one of those things, we'll get used to it. Modify, align that guy to that guy, and flip. Whoops, flip. There we go. And capture position. And can I move this? No, I can't move this out technically speaking because we're aligned to it. I shouldn't be able to move it at any rate. It looked like it actually was going to let me. It did look like Fusion was going to let me, but Fusion should not let me because Fusion does not have a because Fusion should have a history, and therefore I would be corrupting the history there, in theory, but it doesn't. So we are just going to come back in here and adjust our draw, make a new drawing instead, because may as well practice what I'm complaining about here. This is what would have to happen if I was doing it that way, because I aligned not to the top of the extrusion but to the bottom of the plastic piece. And actually, while I'm here, let me turn this guy off, turn that guy off, and project this guy too, because we now have these teeth that we want to put a little insert for. So I will go ahead and run a line. Well, first let me get this box in. Let me get this box in first, because this box is easy. And I know I just did that point in the corner, which may come back to bite me, but it's okay. Give myself just 3mm right here. No big deal. These guys can be construction lines to make my extrusion easier. And then let me turn these guys off so I can see easier, because we want everything to be easier. And I am going to construction line all those. Toss this line straight across, that line straight across, and then we will go collinear with the edges of the teeth. And we should be hunky-dory at that point. And actually, I'm going to turn that back solid because I forgot I have to actually add this in first. So, distance to object. There we go. And then we can do that trough that I just designed. That guy. And bodies to the top of the teeth. Hopefully they're only like 3mm. That way it doesn't wreck my integrity here. Yeah, it looks like it's probably about 3mm. I will open it up, obviously. Offset it, you know, for printing. But it shouldn't be that bad. Boop boop, and boom. Minus 0.05. Ookie dookies. Turn those back on. And now we got to do the motor itself. So let us go ahead and grab that guy. By 47. Did I Control Z and delete all the other stuff in here? Where is your pulley? Did I get rid of your pulley? I apologize if I got rid of your pulley. There it is. Okay, cool. So we will go ahead and get this aligned. Modify, align that guy to that guy. Looks good. And now we just gotta get him aligned up here. I believe I made this. Okay, yeah, back to it being slightly off, slightly not correct, because the sizes are not exactly the same. It's 1.3, right? I think it is 1.3 instead of, or 1.63 instead of 1.7, 1.66, and mine measured 1.63. So that is not exactly right there, but we're off by a fraction of an inch. I don't actually have a center line on this guy, right? Otherwise I'll use it. If I have a center line, I'll use it. Nope. And shaft doesn't have a center line on it. Nope. Okay. So I don't have a good way to align this vertically, or in this direction at any rate. What I can do. Okay. Here's what I can do. I can go ahead and put the motor mount in there first. I was going to yeah. I was going to do the motor, get this into position, and then do the motor mount. But I could alternatively do the motor mount right now and then add the other one in. And actually, yeah, I left the space for it back here behind the tab, the theoretical tab that I was going to use. Obviously, we did not end up using that tab. We ended up with the corner brackets instead. So I do have space up here for the motor mount in theory. So let me come back up here. Change this, because we're not actually using it, to 3. Hopefully this doesn't break anything. Knock on wood. Which one are you? That one? Let us see. Nope, not that one. That's funny, because that looks like that one to me. Yeah, that one does look like that one to me. So what happened here? Huh. I am clicking. There we go. Okay. What I wanted to do here was replace this with Alright, let's turn some stuff off because I keep on tilting around here. Trying to avoid seeing stuff. So we are just going to get the stuff out of my way. So this now, my plan was to get this to here and then that to there. Okay, this is just going to get deleted at this point then, if you are going to be a pain in my butt. What happened here? Holy cow. Okay. We're coming all the way back. That's fine. I don't mind. This guy is no longer collinear with that. And now is going to be collinear with that. This is what I was trying to do, was just to get this used as the motor mount since we're not using it. And it looks like I Control-Z'd all this stuff back on, making my life miserable. Cool. Good deal, good deal. Do-do-do. Dun, dun, dun. Why do you do that? I actually do not know why you do that. All you have to do is move this guy here. Fusion. Don't be a dumpkoff. Alright. Okay. Something is terribly wrong here. This needs to be centered on that. That, I do not understand why this is happening right here. I pretty clearly said that you needed to be here. Okay, there we go. There is the motor mount. And again, we will round these guys off now. And we will get some complaints because some things most definitely broke when we did that. Okie dokies. Well, we should have gotten complaints. We didn't get complaints, so I'll take it. So now we can go ahead and extrude that up to be our motor mount wall. From object here, and we want 1.7 inches, and then I can go ahead. Point being is we can jump forward in time, attempt to jump forward in time. Where's my alignment feature for the motor? There it is. And turn it back on. There it is. Align. And now we can grab the center point of this wall and put it on the center point of the other one, and we are good. There we go. Now we have everything lined up. Turn the motor back on, hit OK, hit finish position, and then start tracing out the outlines for the motor to attach. The last thing, yeah, I don't really think we need zip ties over top the back of the motor. It might be a good idea, but we'll see what happens without them. We'll see how bad this plate flexes, just being the only thing holding the motor in place. We may want to strap the motor down to the plate with zip ties, but again, I want to see what happens. So, I don't know why I'm in the press pull section right now. We can come in here, and this is front of plate, front of motor mount. Front of Z-axis motor mount. Project off the face of the motor. There we go. And this time we don't have to do any slots because again it gets tensioned from the bottom. So we just grab these holes, extrude them out, and on the big hole add a good bit of offset on the big hole to make sure that it is more than wide enough for the motor, and the motor does not get caught on it. The motor plate rather, because these things, the bolts are the things holding it into place, so it doesn't matter how tight this circle is to that embossed thingy chamfer. Alright, there we go, there we go. This pulley is technically not in the correct place at this point. Let us find that joint. I'm guessing it's this guy right here. Disable it for a second and modify, align the inside view with the inside of that. Hit OK and capture position, and that should unsuppress if I recall correctly. No, it doesn't look like it did. Okay, so unsuppress. Alright, you are deleted. As built, that and that. When in doubt, just destroy everything. Alright, there we go. So, we are now at the point where this guy, well, first off we need feet, and second off we need a reliable way to attach this guy. So I guess feet first. That would be in the y-axis is where we should be putting this. It has been a while since we've been to the y-axis. Okay, that's the extra one. That's the one that we made all the clones off of. I just want to turn stuff back on before we leave the z-axis. Now we can turn it off. And where would the bottom of the bed be? That is outside right side, it looks like. Or outside left side, rather. Okie dokies. Left extrusion. Z mid-plane, nope. Bed assembly. We have a bunch of stuff in here, but maybe we can find a bottom of. Backplate construction. That is. Micro switch. We did not do our limit switches for the Z or X. Those are pretty simple, so I'm not going to bother. Doing them on stream. I'll do them off stream. Backup bracket. So not in here. It's possible that I don't have a bottom of extrusions just because we were using the floor as a reference. Let's see. Checked all that, so yeah, I don't see any. Well, I'll double check the left and right extrusions. Yeah, that's the Z mid-plane. I don't think I checked the right extrusion. I think I skipped over that. Oh, that's the front extrusion. Okay. Right extrusion. Z mid-plane, okay. Because it's a mirror. So we do not have a bottom extrusions yet. We'll put that one in. Alright, there we go. And now we can do some feet. So, one of those things, feet, and this is the reason I kept on putting them off, are extremely simple. And they're especially simple if you want to just use T-nuts instead of designing in the T-nut feature to the feet. It's not unreasonable to design a T-nut feature into the feet, but at the same time, I am going to opt to use T-nuts because I have them. So one of those things, we will just create one and then we'll mirror 3 more across and then we will be done. And furthermore, any feet you find basically on the internet should work for 2020 extrusions or 20 profile extrusions even, because they all basically have the same exact shape and size. So whatever you end up with. Again, I'm just going to do M4s here. And to keep things simple, I think I'm just going to go with round feet. So I will do this. I will project out one side. Make that tangent to the foot. And then we will just get a little narrower at the bottom. Finish. For the offset for the feet, let's see. Let's do a full inch. So 25 millimeters. Oh, actually. Alright, let me Control Z some stuff. I wasn't expecting to have to Control Z that much stuff, but let me go ahead and get new component, feet, new component, foot, And then come back up here to bottom extrusions and redo everything we just did. That side too. I think that's the side of the extrusion. It's hard to tell at this point. It looks like it. And this here. That there. Bottom. Let's turn some of this stuff off. And tangent. That feels a lot larger than it was before, so I wonder if I grabbed the wrong thing the first time. And I'll just make this tangent to this. The placement of this is kind of arbitrary, but bottom extrusion 25. Project that. Okay. And we'll make the bottom part of it 12. Finish. That is actually surprisingly narrow. Okay, that is not going to be 12. That is going to be a 5mm. So in half is 2.5. A 5mm decrease on the radius. Let me come back in here and make this a construction line to make my life easier. Alright, it still feels a bit narrow, but we'll live with it. I'm used to seeing fatter feet. But that is okay. But it is okay. New body is correct, and yeah, I was gonna say I didn't think it was gonna actually give me the hole in the middle there, and it didn't. So we will go ahead and just toss that hole through. Distance all. Wookie dookies. Bottom of feet. And the fact that I made these feet 25mm, a full inch, does give us a lot more room to put a fit and extrusion in on the bottom for the z-axis, more specifically, is what I meant to elucidate. Come up to feet, and I think the y, yeah, I think we're mid-planed on the bed off of the origin, and that hopefully hasn't moved. So I'm going to go ahead and just start mirroring components, feet, off of the origin. Looks, it's right there. Should be fine. And furthermore, this is just a CAD. This isn't, you know, it's not going to print it out like this to begin with, so doesn't actually need to be exact. And now we can come up here, modify rigid group. Don't include no, stop. Extrusion, whoops, not that. That and that. Okay. Rigid group, do not include children. That, and that. Okay. And then we can grab a color. Plastic. Actually, I don't think we've used, well, the corner brackets are black, but I don't know if that counts. I was just going to say, I don't think we used black yet in this design. We did use orange. Brown, purple. Alright, yeah, let's just use black plastic for the feet because, let's use white plastic for the feet. I take it back. Nah, black plastic. I should have done this before I mirrored them to save myself a few seconds. Huh, that is hilarious. Okay, there we go. And now I also want to white. The reason I changed my mind from white is because I want to do the motor mount up here in white. This is glossy. Let's grab matte. There we go. And we can come back over to here now. Again, this is going to be a little sketchy. Actually, it's not going to be that sketchy. Okay, so I can put the extrusion on the ground, just flat on the ground. And then we can create slots on the part that will attach it to this extrusion here. Okay, that's how we can do this. So, grab some water really quick. Let's see. Where am I at? Why am I lost? Oh, it's the Z-axis. That's why I'm lost. That would make sense. Okay. I want to come down to the Z-axis pulley block is what I'm going to rename this to at this point. I am going to come in here and then I'm going to grab that random T-nuts extrusion that's sitting around here and create another boundary fill. Okay, fine. I gotta actually click it. I can't click it in the window, in the browser. Are you sure? New component. Turn the other one off so I don't accidentally interact with it. Z-axis base extrusion. And actually, we could do 2. Just because I'm so paranoid, we could do 2. That doesn't sound like a terrible idea. So modify align. Instead of aligning on center, we'll align on this side. Modify align. This should be able to go like that. I don't see any reason why it can't go like that. Just saves us a little bit of height. Okay, yeah. And then we can extrude this out. Capture position. Extrude this out. Distance to objects. Oh, hold on. Let me get actually inside of here. Capture position. Extrude. Distance to object. I'll go all the way to back end in the CAD at least. And then all the way to the wall. There we go. And then we can mirror this guy. So actually hop back up to Z-axis pulley block. Mirror this guy over. Because we'll go ahead and use 2 instead. And where did my midplane go? That should be Z-axis extrusion. Which one was it? That guy? Okay. Because this guy should be centered on that, so that's why that works. And now let's see, how do I want to design this? So those nuts are completely within this wall here, which means that I can use this wall right here. Let me see if I got a construction line corresponding to that. Does not look like I do. Okay, this is top of tensioning base. Okie dokies. So I'll go ahead and put that wall in here. Actually, I'll put the wall over here because this is the front side. Front side of pulley block. We'll grab that. We'll go ahead and make a wall right here for these extrusions to attach to, and that will get the extrusions attached to the pulley block, and then we will do the attachment from the extrusions to the other extrusions. And aside from, again, the limit switches, that should be everything. So we are just about done until I remember that there was something I'm totally forgetting. So look forward to the most unexpected part 20. Coming soon, TM. That's funny. Where's the... Oh, I am blind. I was going to say, why can't I find the rest of these bodies to get out of my way? It is because I am blind. Yeah, I guess I may as well go all the way to the bottom of the extrusion. So let me go ahead and grab that. Okie dokies. And the reason why this doesn't need feet as much as the other thing does, as much as the rest of the bed does, is that whether or not this is wherever this z-axis is standing is kind of irrelevant, because that just changes our maximum height and our minimum height. So we just use the limit switch to set that, and then we set the maximum height to something safe, something that we'll never have to worry about. So that's why I don't have to worry about leveling this right here. Let us grab center of that. Go center. So fun fact, I don't know whether I grabbed center of... Okay, it does look like I grabbed center of the extrusion. Because I centered up over here on this wall, because technically I'm doing top and bottom here, it's not as exact. I'm probably just being paranoid, fact of the matter being, but it was something for me to worry about. Let me Control Z that and turn the extrusion off first, in case Fusion decides to import another projection. You guys are actual holes. You are not what you call it, construction holes. These guys are, however. And once again, we'll just stick with the M4s because, frankly, I have plenty of M4s sitting around. Do 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 do. Boom 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 boom. Distance to object. There and join. Yeah, okay. I just wanted to double check that we had enough space right here and I wasn't accidentally covering up the hex nut. Boop 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 boop. Where am I at? I want that, and then I want this guy. Okay. And that is going to have to be changed. Let's see if Optimize works today. Optimize did not work today. Who here is surprised? Optimize used to work wonderfully. I have no idea why it doesn't work wonderfully anymore. I have decided to kick these back just a hair because I am once again feeling paranoid. I don't want this sitting directly on the floor and therefore pushing the extrusions up. I much prefer the extrusion have the weight on them than the plastic have the extra weight of the extrusions on them. These extrusions right here. So rather than the plastic holding the extrusions up in the air, I'd prefer the extrusions be holding the plastic up in the air. And now we can... so this is one of those funny things where that made sense there. These extrusions maybe should have been in the Z-axis component, or maybe I should have made a component and moved this Z block at this point and these extrusions into another one. Point being is that we're kind of a little bit too nested at this point. It's not, well, it's not nested correctly. It's more the correct way to say it. But that's fine. That's fine. Really, the other way to resolve this, let me just Z-axis attachment point, I guess, attachment plate. Z2 axis attachment plate. There we go. So what I was saying is the other way to solve this actually is this body right here probably should be its own component. Then this would make sense right now, the way I've got this set up. So this would be Z-axis base at this point, and this guy would be Z-axis pulley block. There we go. So now this file structure makes a lot more sense. It's a minor thing, but I figured I'd mention it. We do have this outside left hand side, as I noticed before. Construction Z, okay, it's not there. Outside left base extrusion, there we go. So I will use that. I will project out these guys because these guys are what I'm attaching. And this is where I'm attaching to the center point. And I will also, for good measure, grab the top of the extrusion. Attempt to grab the top of the extrusion because it is really hard to see when it's invisible. Invisible things, hard to see. I bet you didn't know that. And then the next thing to this. Oh crap, what did I just do? Okay, it looks like that didn't actually do anything. I grabbed the timeline, or the browser rather, and dragged something, and I was deeply concerned I just screwed something up. Did not happen though. Anyway, for the back plate over here that attached the motor mount on the y-axis, I tapped those guys and drilled them in. The fact of the matter is that I might have screwed them in, rather, not drilled them in. I tapped it and screwed them in. I might have tapped that slightly crooked, which is why part of the reason why the base is crooked and needs feet. That is definitely a possibility of something that might have happened. So I am less inclined to tap the ends of these guys and more inclined to make an L bracket that that attaches to it. And now that I've said L bracket, nah, I can't use the corner brackets though. Yeah, I can't use the corner brackets, so that's fine, that's fine. Although the question is if I'm doing an L bracket, I probably should, actually just hit Control Z a whole bunch. Where are we at right now? Redo rename is correct. There we are. And redo show hide. Alright, here. Okay. So I probably should do the L bracket because it's an L bracket from the side. And this is this guy right here, right? We'll do the front side. That way it's easier to see. So, gonna hop in here, toss this on here. Front side of Z-axis front extrusion. Okie dokies. Do not do this though. I want to hop back up at here and then do that. And again, we will go ahead and do our L bracket first and then put the holes in after we have the L bracket in place, because that should be easier. And one of these things, I'm just having a difficult time seeing what is the top here. I think that's the top. Yeah, that looks like the top. Okay. So that is my references. We can turn stuff. Don't turn the stuff we're working on off though. Boink and boink boink and boink. There we go. All right. Here is my L bracket, like this. Again, using code linears because they're easier to delete and modify. And then, so this actually does not have anything torquing on it, I don't think. You know what? Let's just be safe. We'll be safe with this. So we'll do 6 and 6. It's probably overkill, but that's fine. That's fine. The length here does not have to be super long. Let's see. If we're using an M4 bolt, that's 4 millimeters plus a couple millimeters, so that's like 10 millimeters for the head ish. Probably less than that. Probably closer to 8. I don't feel a need to put more than one bolt into each side, honestly. So since I don't feel that need, we honestly can probably just leave this at 12 and call it a day. Okay. 12 is shorter than the other side of the L, which makes me unhappy. So we're just going to do this. There we go. Equal. And we can come back up here and extrude all the way to the other side. Distance to object. And then we can put our holes in. Top of base face, I guess. Top of base face. Project out that and that to reference, not that though, to reference our holes off of. That is fine. We don't have to go the full way. And now all that can be constructions, and we can go ahead and put our holes in. Bum 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 bum. Okie dokies. And now the front face. Front of Y axis face. And we do the same thing over here. Easy enough. Actually, so we can do it any way we really want to. I guess what I will do is I will use these guys to key off of for where we're putting the bolts. That way it's in line with the other ones. The bolts actually can go anywhere in this face. It doesn't necessarily matter, but I'll key them off of where we got the other bolts so that they're in line. And then I just need the y-axis to grab the center line there. Okie dokies. Okie dokies. Again, this line doesn't technically need to go all the way across, so long as it is square. And I should have drawn these guys in before doing my construction lines. But this is going to be simple and over very, very quickly, so it doesn't necessarily matter. 4 and finish and extrude. Distance to object there. Okay. And now we just throw the joints in and we are good. Again, the micro switches still need to be designed, but that is less of an issue. That is just frankly a very simple matter of creating some plates and attaching them to the extrusion. So it's not something I'm particularly concerned about doing online. As built joint, or actually rigid group. Do not include this up front, guys. Okie dokies. There we go. There is that. There's that. There's that. And not that guy though. We don't like that guy. And I believe that is the entire CNC machine. So we'll just add a little bit more color. Plastic. Do we have dark blue yet? Okay, we do have dark blue over here. Here is some gray. Gray there. If I had my pink, I'd use it. I do not, though. Alright, time to make him a new color. Let's see. Color hex. And let's grab a random color here. I don't want to grab pink just because, so it's a pseudo random color because I don't want to grab pink because I'm already adding a pink. Let's see. I'm going to close my eyes here and click. Okay, we ended up with something of a orange. So I'm going to get info here and try to find something a bit interesting looking in the related colors. Let's see. New colors. New colors are hard. Alright, I like this turquoise type color. That's an interesting color. And you know what? This is not quite pink. It's kind of a rose red. So I'll grab that one too. And while we're here, I don't see any good green sitting around. Let's try to find a good green. What greens do I already have? Do I have a lime green? I don't think I have a lime green. No? Okay. This is kind of a lime green. Do I want it a little lighter though? A little more intensity. Yeah, let's grab that one. That one's slightly more intense. Okay, cool. Alright, time to add some colors. Duplicate. Edit. Lime green. And your color code is... can I do hex? I can't do hex. Alright, what's my RGBs here? RGBs 152, 212, and 20. Okie dookies. Done. And let add that in. Maybe not there, just because that's so close to the bed. We'll put it over there. Next color. I was looking for this turquoise color here, which is why I clicked here. Alright, so this guy, let's grab a blue and duplicate a blue. Edit. Maybe turquoise. I think it's more of a turquoise. How do I even spell turquoise? Is that right? Alright, and RGB is 16, 107, and 95. Okay. Put that there. And now that doesn't really work next to the green. So this will be getting that rose red that I was talking about. But at least we have that color for later. So, doink. Grab my red, duplicate my red. Edit. Rose red. 231. Whoops, 231. 49 and 49. Okay. That's pretty close to the red we already have right now, so let's change that a little bit. So what happens if I go this way? I do not notice a difference. Okay, fascinating. Edit. What were you originally? 49. Let me see if on this page I can't get something. Yeah, how about this guy? So 235 90 90 is our new attempt here. 235 90 90. Done. All right, there we go. That's slightly more noticeable different from the red in the back. All right, cool. So, oh, there we go. I haven't colored this guy on the end yet. You are now the turquoise color. And that is the CNC machine, again, with the exception of the limit stops for the X and Z. That is the machine done. Yay! We did it. We're all done. And by all done, I mean I got to get it all printed, and then we got to program an Arduino to run it. Actually, no, that's right. I have the Creality silent board sitting around, so we will reprogram that instead, update the firmware on that to run our thing, and do it off of G-code. Maybe write a program to do our G-code for us, maybe. It's an idea. I've done that before. Yeah, alright. So, this was a fun adventure. Adventure's not quite over, but this is definitely a turning point in said adventure. Because, again, the next part is actually getting it working in real life. So it is designed. We have most of the parts printed. Just have to print a few more parts. And then we are putting all the electricity and all the code together. So this is awesome. This is almost there, or almost done. And then it's just a matter of using it. So, if you have been following along on this journey, thank you for listening. If you have not been following along on this journey, I don't know how you're listening to me right now, so I guess I don't have to thank you because you won't know one way or another. So, anyway, looking forward to the rest, the continuation of this over on the physical and programming side of things. And do please do please be sure to stay tuned is what I was trying to say there. I'm trying to find in browser. You should be invisible right now. And see what happens with the rest of it and get to see it in action in real life. So, as always, well, before I sign off, I have been putting off the stream animation program for a while now. I kind of feel like putting it off a little bit more because I got a new jigsaw, and something that when I finally got a jigsaw, and by new jigsaw I mean this is my first jigsaw. I've borrowed my brother's jigsaw when I needed one before, but I got myself one because I want to start doing more woodwork, and additionally I do not have the space for a bandsaw. That being said, that is my tangent, my segue into, instead of the stream animation program tonight, I kind of want to set up a jig for my jigsaw to act as a bandsaw replacement, because again I do not have the room for a bandsaw, and that makes things a little difficult. Some things that I want to be doing and can't, and we do not have a vertical bandsaw at work, unfortunately, even though we really should have one. It would make life easier. We do not have one. That's the fact of the matter. So, I am, for my personal hobby use, looking to convert this jigsaw into a pseudo bandsaw for such uses. And that is something I want to get done, and therefore I am tempted to do that instead of the stream animation program tonight. But we probably will end up doing the stream animation program because I've been putting that off for way too long, and it really needs to just get settled. So, again, assuming something doesn't come up and I do get to stream a third time today, that is what you can look forward to tonight. Otherwise, now I will sign off. So, thank you guys for watching, and I hope wherever you're at in the world you have a great and wonderful day, afternoon, or evening, and I will catch you next time.